Uh, I am excited to present a Bluetooth-based reverse parking system which is organized around two integrated subsystems, sensing and actuating, which is able to communicate wirelessly to help a driver gauge, and that can be able to have the driver gauge remaining clearance as per the car backs into a garage. The sensing subsystem is a wall mounted, you can say, and it is been equipped with some kind of sensor readings that can be able to captured by a Raspberry Pi, which serve as a central host and edge processor. In spite of that, the Raspberry Pi reads a light sensor data and which can be able to apply if we talk about the filtering the data to get the smooth fluctuations and translate the raw readings into a very meaningful proximity magics. This metric is not just about the transmitting the real life data, but it's about doing the meaningful proximity metrics into the car itself so that no car can be able to have a damage. Although the Arduino interprets the incoming payload with the help of the pulse width modulation to as per the vary into the LED's brightness, and which can be able to modulate the buzzer tone itself. We can have this clearance by creating a graduated and the remaining clearance. As per the larger distance, the LED automatically emits the dim light that increases, and the buzzer will be able to get the tone or having their duty cycles respectively as per their own cortical cues that can be able to visually and auditorily communicates urgency without requiring the driver to take their eyes off the mirror. Now, if we talk about the hardware details, we like I have been integrated a subsystem that have been a leverage well-mounted light sensor, which I use that is BH1750. All right, we have been connected to the Raspberry Pi. Now, if we talk about like how the communication is being going on with the help of the Python script with the Raspberry Pi, so I have the conclusion with that as well. We are using this sensor via I2C communication. That is really helping to filter and mapping the sensor value to a user-friendly data as per the distance. Also, the processed value is being packaged into a very compact Bluetooth message, and that is being able to transfer into a low latency profile. On the car side, if we talk about the Arduino Nano 33 IoT is being initialized a Bluetooth serial connection, and that has been able to control the PWM. So this dual modality ensures both the visualness and the audibleness cues supporting the driver even when the dashboard lighting is low or ambient noise is high. In terms of software architecture, the sensing subsystem uses the Python running on the Raspberry Pi to handle the sensor reads, able to filter the data and Bluetooth transmission. Although we have used a Bluetooth GATT like service, that is a kind of a serial profile, depending upon the chosen pairing approach. Now the system emphasizes the low latency, means we can have the end-to-end round trip time is minimized through the efficient code path itself, and no other minimal protocol is overheading the choice of Bluetooth. Also, the calibration and the testing, we first calibrate the light sensor with the garage to establish a baseline ambient light level, and it will be surely determine the mapping between the raw sensor with the meaningful distance values. So this is how gradually the verify end-to-end latency increases as per the LED, and the buzzer responds smoothly without abrupt changes. So from an integration standpoint, the system is designed and with modularity in mind. The sensing and actuating subsystems operate independently, which is being able to desire the same architecture that can be extended to include the additional feedback channels, such as haptic feedback in the steering wheel or a dashboard message. In conclusion, this Bluetooth-enabled reverse parking system demonstrates a practical and a very bridging sensing actuation in a garage environment. So by having this leverage of Raspberry Pi with the Arduino Nano 33 IoT for the car side actuation, we shall receive a responsive, intuitive user experience that helps the driver's coach to get remaining clearance precisely, and it has the modular design, very careful, calibrated, with the emphasis on low latency communication so that it can be able to have a strong candidate for real world deployment for the future use itself. So that is what from my side this task is, and thank you so much.